Hi everyone, so today I'm going to be doing a practice problem on null hypothesis testing and calculating the p-value as well as the type 2 error. First off, here's a practice problem I found. Right off the bat, I'm going to establish my null and alternative hypothesis. So the null would be equal to 85,000 and the alternative would be that realtors make more than 85,000, so that's why I put a greater than, and the sigma is given to us as 12,549. And it's one-tailed because it's greater than. So step 2 is figuring out which statistical test to use. I'm using z-test because I know the population standard deviation and the sample size is over 30. Now I'm going to find out the confidence level. Since the alpha is given to us as 5%, the confidence level is 95 because you do 1 minus alpha. For those who do not know, alpha is the probability of making a type 1 error, which is rejecting the null even though it's true. Now we are going to find the z-score, which we are going to do by using the norm-in formula. And since 95% is the confidence interval, we're going to put that as the probability, 0 as the mean, and 1 as the standard deviation because it's a normal distribution. So in the end, we get 1.64 as the z-score. So step 4, we are figuring out the standard error, which is basically the standard deviation of the sampling distribution. Thus, I am doing the population standard deviation, 12,549 divided by square root of 36, and this is a formula that you will find. So after that, we're looking for greater than 85,000 for the hypothesis testing, which is why we are only doing the upper limit. So the formula to do so is sample mean plus or minus the standard error times the z-score. In this case, we are doing 85,000 plus 1.64 times 2,091.5. And this, you can see, is the result of 88,440. The interval estimate gives us an indication of how much uncertainty there is in our estimate of the true mean. And this we will also use later on in hypothesis in the type 2 error testing, because this is the critical value. Okay, so step 5, we are going to input our sample mean given to us and the sample size. So sample mean is 88,595 and the sample size is 36. Okay, so step 6. We are going to calculate the z-score, which shows how much standard deviations are above or below our hypothesized mean. I'm going to subtract the sample mean from 85,000, which is our hypothesized mean, and then you divide it by the standard error, which is basically the same thing I'm doing right here. I'm doing population standard deviation divided by square root of h19 of 36, which is basically, I could just put this. So in the end, I have the z-score of 1.72. Okay, so after that, we're going to find the p-value, which calculates or determines if we reject or accept the null. So if the p-value is lower than the alpha, we have to reject the null because it indicates that there is a less than 5% chance the null is correct. I used 1 minus normal distribution, and then I put in the z-score that we got in earlier, which is 1.72. And then after that, I ended up with 0.04. Since it is lower than the alpha, I'm going to reject the null hypothesis, which means that we believe the realtors actually make more than 85,000 in a year. So adding on to the problem, what is the probability that the researcher will fail to reject the hypothesis and that the mean is 85,000 when it is actually 89,000? I'm going to put 89,000 as the null, and then I'm going to find out how many standard deviations are above or below our hypothesized mean. I'm going to use the same formula earlier, except I'm subtracting from the upper interval limit right here, and then from the null, which is 89,000. And then I divide it by the standard error again, which I end up with a negative 0.27. So right here, I'm finding the probability that the researcher will fail to reject the hypothesis that the mean is 85,000 when it is really 89,000. and I find that there is a 39.45% probability. And so this basically means that there is a 39.45% probability that the researcher will fail to reject the hypothesis that the mean is 85,000 when it is really 89,000. And here is a visualization of the normal distribution curve. Thank you. Thank you for listening.